All right, so next part of this then is we have a 30, 60, 90 triangle with a long leg of 10 inches, or 10, we'll make it 10 feet, and we want to find the perimeter. The question obviously would be, perimeter of triangle would be way better worded, but I don't want to have to write for a year or so. So we know we have a 30, 60, 90 triangle, and they've told us the long leg is 10 feet, and we want to find the perimeter of the triangle. So I would definitely start with drawing a triangle. So I'm going to draw my triangle. I know I have a 90-degree angle. Where I put my 30 and my 60, totally up to you. If you did yours different than what I would do, then it would just be reflected and it would be fine. But I'm going to put 30 here. I'm going to put 60 here. Okay? Now, even though you don't have to know the labels because that's on your reference material, you do have to know how to figure out which is the long leg and which one is the short leg. So how would I figure out in this triangle which leg of the triangle is the long leg? What does it have to be across from? Well, across from 90 is the hypotenuse. That's not a leg. So the bigger angle. So this is definitely the hypotenuse. So the long leg is across from the 60, where the short leg would be across from the 30. So this is the long leg, and it is 10 feet. Okay, that's what they gave us. Yes? Okay, well, the biggest angle is 90. You're right. So that's why the hypotenuse is the longest side. But in a triangle, in a right triangle, you have two legs and a hypotenuse. So it is the longest leg because there's only two to choose from. Does that make sense? Yes? Okay. No, that's fine. I might not have worded that very well. But no, hypotenuse is definitely the longest side, but then you have a short leg and a long leg, and 60's across from the long leg, 30's across from the short leg. Then when we go to the reference materials to look at how to label this, you want to make sure that you're paying attention to where your angles are, or without even necessarily looking at that first so that there's not a lot of confusion there. Across from 30 is the short leg, and that's one reason I like to use S. Not for side length, but for short leg. So if that's the short leg, then when I look at my reference materials, oh goodness, what is going on here? I don't know why sometimes when I open things it just doesn't. Well, you know. There we go. Across from 30 is the S, so the hypotenuse is 2S. S times the square root of 3 is the other one. Lord. There we go. So S, hypotenuse is 2S, and this is S times the square root of 3. Something that I have to remember because I have the reference materials. I just have to know how to apply it, right? So when I label this like this, I have just set up a little equation here. 10 equals S times the square root of 3. In order to figure out the other two side lengths, I need to know what S is. So I'm going to divide both sides by square root of 3 and get that S equals 10 divided by the square root of 3. That makes sense? Now, if we were really doing a special right triangle lesson, we'd talk about rationalizing the denominator and doing all of that. We don't have time for that. I don't want that to confuse anything. You have access to a calculator for the whole thing, so we'll just talk about how to manage it that way. But again, if you know how to do it, knock yourself out. Don't want to completely lose anybody. So I have that this is 10. This is 10 divided by the square root of 3. So if S is 10 divided by the square root of 3, then 2S is 2 times 10 divided by the square root of 3, which I do not need to do crazy things with. Nothing fancy happens. The multiplication is very easy, and that gets me 20 over the square root of 3. So here are the three sides of the triangle. To find the perimeter, I add them all up, right? So I would add 10 plus 10 divided by the square root of 3 plus 20 divided by the square root of 3. Now, I cannot combine all three terms without getting a common denominator. That would, I highly doubt, be expected here. But these two do have a common denominator. Don't think that it's any more difficult because there's a square root there. It's like 10 thirds plus 20 thirds, right? Just think of it that way. So when I actually combine those, I get 10 plus 30 divided by the square root of 3, which I would be shocked if an answer choice looked exactly like this, but I guess it's possible. But here's what I am pretty confident of, is if you have 4 answer choices, some of them, at least one of them, maybe more, would not have a whole number that was 10. The whole number would be something else, assuming you'd make a different mistake. So you could eliminate some right then. Then the second term that would have the square root in it, again, if you know how to rationalize, knock yourself out. It would look, you could do it that way just fine. Or since you have access to that calculator, put the second part into the calculator, put all the other second parts in and see which one matches, okay? Not the best way I should be teaching it, but when we're talking about test taking strategies and just trying to review stuff, it works. I mean, you do what works, okay? We good on that? All right, so now we're going to come back up here to these other two blanks because our spacing is weird on all of this. And the next one is, I have an isosceles right triangle with perimeter 8 plus 4 square roots of 2 feet. I want the find a leg. It would really say find the length of a leg. What's another way to say isosceles right triangle? 45, 45, 90 triangle, right? They're the same thing, okay? They are the same thing, so I'm going to draw a triangle. Even if I wasn't sure about that, I need a right triangle. This is what makes it an isosceles right triangle. So again, hypotenuse is the longest side, and then I have 2 legs that would be congruent. That's what makes it an isosceles right triangle. Angles are 45. I don't know that I necessarily need the angles for this, but I do need that concept there and the labeling. So I don't know, like it gave me the perimeter, so I'm going to go back to my reference materials, take the labeling off of this, and I would put an S here, an S here, and an S times the square root of 2 here. Now, it's likely that you personally may not need to do any more work and know what the correct answer is. The first time I said that today, somebody was like, yes, and they screamed out the total wrong answer. So I was like, all right, thank you for participating, but I want to show you what you can do to make sure you're right, just so that we know what to do here. If I found the perimeter just with my green labels, and again, those are not 5s, those are S's, I would do S plus S plus S times the square root of 2. Again, I can combine like terms, so I end up getting 2S plus S times the square root of 2. That's basically, for whatever side length I would have, that's how I could find the perimeter. Then, when I look at what they gave me here, they gave me 8 plus 4 times the square root of 2. And if the orange has to be equal to the blue, what does S have to be? 4. Okay? You can look at it one of 2 ways. 2S equals 8, and I get 4, or if these are equivalent, clearly that has to be 4, and it's just asking me for a leg, and that is 4. Most of what would show up with special right triangles for you is not going to require a whole lot of work. It requires an understanding of the concept and the labeling, and just kind of looking how things match up and what the patterns are there. What questions you got? Okay. And then this next one, we have an equilateral triangle with perimeter, so I'll just put P. P equals 48 inches. And then we want to find the height. All right, so what makes an equilateral triangle an equilateral triangle? What's true about it? Or what do you know about it? Say that again? Has the same side lengths, yes. So since it's equilateral, equa meaning equal, lateral meaning sides, all three sides are congruent. So when I draw my triangle, I need to attempt to draw it not like a right triangle so I don't confuse myself. I mean, it wouldn't really matter, but again, we don't want to confuse ourselves. So an equilateral triangle basically looks like this. And I'm looking for the height. So the height goes in right here. And all three sides are congruent. If it's what else besides the sides are all congruent? The angles. So if I have three angles in my equilateral triangle, what's the measure of one of them? 60. Good. It's 180 divided by 60. So this angle here is 60 degrees. So is this one, right? And I want to find the height. So I have this special right triangle right here that lives inside my equilateral triangle. I need at least one side length to do something. They gave me the perimeter. Can I use that to find the length of a side? What would I do with that 48 to figure that out? Divide by 3. 48 divided by 3 is 16. Do we need to be able to do that without a calculator? Yes. If you are allowed to use one, use it so you don't divide wrong. Okay? There's no shame in that. You don't have to be like, I don't need that. I mean, we have to be able to do those things because you don't get it on the entire AP exam. But even with simple division, do it on the just to double check you're not thinking weird because you're stressed out and you're trying to hurry and whatnot. So the side length is 16. And then what I would suggest happens, especially because, first of all, I drew my picture a little too small, but I know quite a few of you draw some really small pictures and it's hard to label things, is I would take this triangle here and redraw just the 30, 60, 90 part of it. That also helps you with all the extra stuff just being gone. That's your height. That is 16. This is 60. So what's this other angle? 30. Okay. And then we're going to label our 30, 60, 90 triangle. So the short leg is across from which angle? The smallest. So across from 30 is your short leg. I think it would be good practice to label that. Then go get the pattern off of there so you can make sure if something is labeled right, then you can put all the other stuff. This would be 2s. This would be s times the square root of 3. So if 2s is equal to 16, what is s? 8. And then what is the height? 8 square root of 3. Okay. The computations should be fairly simple. But if you don't know what an equilateral triangle is, you can't even get started. If you don't see the 30, 60, 90 in there, if you don't remember that the height is always perpendicular, things like that. Okay, what questions do we have at this point? Anything? All right, grab your second sheet of paper. And so this is going on 45. And before we even talk about what's on this paper, just like on the other one, we're going to use the free space to do some examples here. So I'm going to start off by giving you this triangle. We're going to call it ABC. And we're going to label this X, Y, and R. And we are going to find the sine of A times the tangent of A. And this is almost, this is just like one of the questions that was on what you were working on the other day, whether or not you got to that one. But I changed it a little bit. But people were hesitant on this, even though they totally had the skills and the knowledge to do it. It just seemed weird because we've done a lot of ratios with numbers. These are variables. And what they're asking you to write just seems odd. And I'll agree with you on that, but we can still do it just fine. The angle is angle A. So I'm using this angle for both of them. My hypotenuse is across from the not across from the longest side. Across from the right angle. Then across from A would be the opposite. And this would be adjacent. Okay. So then I know when I want the sine of this angle, sine is opposite over hypotenuse. This is the opposite side. This is what's labeled as the hypotenuse. So that's going to be y over r. Then tangent. Tangent is opposite over adjacent. So that's going to be y over x. And then when I multiply them together, fractions, you just multiply straight across. This gives me y squared over r times x. And then you find that answer choice. That's all it's asking you to do. It's just asking you, do you understand the relationships? And, very basic question, but looks kind of weird if we haven't ever drawn one up where we're using variables. Okay, we good on that? All right, so one more before we get to these actual notes over here. I'm going to tell you that we have triangle RST is a right triangle and angle S is a right angle. I'll tell you what we're looking for here in just a minute. But with that information, we should be able to draw and label a picture. So here's my right triangle. And it tells me that S is the right angle. So here's my right angle. This is S. That's how I knew how to label that one, because it's the only right angle I have. Which other angle is R and T? Doesn't matter, because you're drawing the picture, and as long as we label it accordingly, it's fine. Because that's a good question that I always get was like, how did you know where to put those angles? It doesn't matter. And if you did yours differently than mine, I mean, S matters, but R and T don't. Then when we label it, our labels will look opposite also, but in the end, we'll get the same answer. It's totally fine. But I would put R here and T here, not because that's what's best. That's just what I would do. I don't know that I have a good reason for that. All right, so that's what I have, but that's kind of all that I know at this point. But here's what we are going to find. We're going to find the cosine. No, let's start with sine. We're going to find the sine of R, the cosine of R, and the tangent of R. And then we're going to find the sine of T, the cosine of T, and the tangent of T. But we're only going to label the triangle once so we can talk about something we talked about yesterday. Okay? So if I'm going to start with the R's, I'm going to label my triangle according to my angle R. This is hypotenuse. This is my opposite side. This is my adjacent side. So here, not only do I not have values on these side lengths, I don't even have variables. But here's another little quick review from geometry. That's totally okay. Because when I want to do sine, that is opposite over hypotenuse. So this side, I can name side ST. ST. You can name it with the two endpoints of the line segment. So line segment ST actually has a line segment above it. When the line segment is missing, it represents the length of line segment ST. That's why notation matters. We've got to make sure we're really writing what we're trying to say. So the length of this side over the hypotenuse, which would be TR. Another thing is if you had to do that and exactly what you wrote down for yourself is not what's there, I could have named that line segment ST or TS. It doesn't matter what order they're in. So don't forget that. But here's one thing you absolutely can't do is I can't cancel out the T's because that would make absolutely no sense. We agree on that one? Okay. So don't go making stuff up. R, that's adjacent over hypotenuse. So that's going to be SR over TR. Tangent, opposite over adjacent, that is ST over SR. Okay. Everybody okay with those three? Now, what I could do here, but we're not going to because I want to look at it a different way, is I could then relabel it with angle T and use this as opposite, this is adjacent. That's totally fine. But one of the things we talked about yesterday is that the sine of one angle is the same as the cosine of the other. So if the sine of R is this, then that's also going to be the cosine of the other angle. So this would have to be ST over TR. And then the cosine of R is going to be the same as the sine of T. So this would be SR over TR. And if you're not super comfortable with that, and you're afraid you're going to mix it up, like I said, you could totally relabel it and it's fine. But then tangent, like it doesn't, it's opposite over adjacent. So when you change angles, these are the two things that switch places, right? So since this is opposite over adjacent, if they flip spaces or places, this has to be adjacent over opposite. So this is SR over ST, which would also be cotangent. So basically the tangent of one is the cotangent of the other, that sort of thing. What questions you got? We good? Remember, I know some of this, I'm going quickly. I might be pushing some of you out of your comfort zones, even though you understand trig. If it doesn't all stick, that's okay. But I think we're going to do enough of it that if some questions come up, if we had done nothing, you'd be like, I have no clue. But because we've done something, you might be able to reason through it and just have a little bit of that knowledge there. All right, so let's go. We're going to kind of skip over all these words, but this angle here, and hopefully you've at least seen angles in the coordinate plane. I think that might also be part of geometry, maybe not. I taught pre-AP and always did a little bit of extra stuff because I felt like if I'm going to do this, I should at least introduce this. So maybe this is brand new to you. It really doesn't matter because I'm going to kind of go through it like it is. The only way you're going to see angles in the coordinate plane on the SAT or PSAT is going to be in standard position. That's mostly the only way we work with them, even in pre-cal, for the most part. So what standard position means is you start with the angle, with the initial ray on the positive x-axis. So think about it being closed like this, right? And then when your angle opens up and swings around, we're going in this direction. My terminal ray, the end of the angle, landed in the second quadrant. So this angle, we don't know exactly what it is, but this is 0, this is 90. We'll say that this is like 120. It's probably more like 135, but it doesn't really matter. If I label it 120, then it represents 120. That is a positive 120 degrees. I could also have negative angles, all right? The negative angles, I would still start in the same spot, but I would go clockwise. So this right here would represent a negative 90 degrees. And here's a way you can remember which one's positive and negative. Okay, again, we're not going to get too much more crazy with that before tomorrow. And actually, when we talk about it, we don't even use degrees. But knowing which way is positive and negative might come in handy. When you've known what the quadrants are for a long time. But I'm quite sure, just like most people, myself included, it took a while, even after I had learned them. Like I knew how to number them, but it just seemed ridiculous to me because we read left to right. Why the heck would you start with 1 there, right? But we start with, that is quadrant 1, because this is where 0 starts with your angles. I start at 0, I rotate around from quadrant 1 to 2 to 3 to 4. So maybe that'll help you remember to go counterclockwise if you just know how your quadrants work. Okay, we good on that? Okay. Even the questions that they would ask you with this, I don't think would get too crazy, but if you didn't even know negative angles could happen or where you get your positive angles from, you don't even know what to think. All right. So then we talk about angles in the coordinate plane so that we can get to our triangles being in the coordinate plane. And so if you have a triangle that they're referring to quadrants in any way, I just want to make sure you know how to draw these triangles. And I also want you to remember this. This is an adaptive test. So if you get to any questions that start referring to anything we're talking about today, where I'm pushing you out of the stuff you really already understand, the first ones you see should be fairly simple because they want to see, can you do these before you get to the more difficult ones? So if you get to one and you're like, oh, that was that weird stuff, don't overthink it because it's probably a really easy one to see if you have any clue before they move you on to the other ones, all right? So before we get to any of that, if I'm here at 0 and I rotate around to get from here to here to get to point P, I get this angle theta right here. And then I can create a triangle. The triangle is created by the radius that goes to point P. The vertical line we drop down to the x-axis. You always make them to the x-axis and never to the y-axis. And this part right here. That's where your right triangle comes in. Now, once you know how to plot points, you've been plotting points forever. So think about how I would get to this point on the coordinate plane. If the ordered pair is x, y, I start here, I go to the right, x units, whatever it is, then I go up y units, whatever y has to be. Then this is the radius, and it's the same all the way around. Okay? Does that part make sense to you? So that's an important connection to make to the coordinate plane. I'm going to draw a couple more things in that are not what you do, so don't do this because I'm going to erase it. Here's how you don't do a triangle in the coordinate plane. It does not happen like this, and you get your right angle right there, because that's a misconception a lot. And then try and use one of those two angles. That doesn't make any sense. The other thing that happens, which is not what should really happen, is that if we rotate around, we have our terminal ray, and then we know that we're supposed to get a right triangle out of this. You do not ever make it with the y-axis. It's always with the x-axis. Always, always. So if you do have that, so I guess this you can draw in. We'll draw in this one. Ooh, that's not even straight. This probably won't be either, but we're just going to go with it. That's better. So if that's my terminal ray, I rotate it around to this point, you always go to the x-axis. That's where your right angle is. And then even though I would have rotated from here all the way around to here to make a big angle, the only angle I care about is this one right here that is made with the x-axis. Okay? And we'll talk a little bit more about that and why that would even come into play in just a minute. But because of this, because really, I can take this triangle, reflect it over here, then I reflect this one down here, and I can get 4 little congruent triangles that we'll look at. Then my sine, cosine, and tangent in the coordinate plane are always the same thing. Meaning that whatever theta is, we know that sine is opposite over hypotenuse. Well, from theta, the opposite is the y value over the hypotenuse, which is the radius. That's where you get that from. If you have to relate sine, cosine, or tangent to x over r, y over r at all, it's okay if you can't remember them. I mean, even when I first started teaching pre-cal, like I knew them, but my brain still went opposite over hypotenuse. Like that was still, and that's where your brains are, which is fine. So if you're here and this is the angle, clearly this is the opposite and this is the hypotenuse, right? And if you do that, you're going to get the y value over the radius. So you can make it make sense with what you understand. Okay, just label it with what makes sense to you. So cosine, adjacent over hypotenuse, that's why it's x over r. Tangent, opposite over adjacent, that's why it's y over x. It's also sine over cosine. I don't know that you really need to know that for tomorrow, but just, again, quick little, how do we put this on the circle? So, over here, let's do this again. Okay, same kind of thing we just talked about. This says the figure shows a circle with a radius 5 centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle intersects a circle at point P. Okay, so again, if it says, it might say something like the terminal ray is in the 3rd quadrant or in the 4th quadrant. Like, why do you even care? Why is it telling me that? It has to do with the signs of the numbers, not the S-I-N-E, but the S-I-G-N. Because again, something you've known forever is in quadrant 1, all of your ordered pairs are positive, positive. In quadrant 2, they are all negative, positive. In quadrant 3, they are all negative, negative. And in quadrant 4, they are all positive, negative. So that's why the quadrant might matter when they're talking about a triangle. So if we do what it just said, which was we started here, this is our initial ray, right? And then it rotates around to end up with our terminal ray in the 4th quadrant right there. So to make my triangle perpendicular to the x-axis, here's my triangle. Now that's a really big angle because I rotated through 90, 180, 270. So this is about a 300-degree rotation we went through. We don't have a 300-degree angle in the triangle. That doesn't make any sense. The angle that we use is the angle that's made with the x-axis, which would actually be the same as if, see this point here just reflected down here? So this angle here is the same as this one because the whole triangle itself just reflected down. You with me on that? So that means when I'm looking at this, if this ordered pair is 3, 4, this one's going to be 3, -4, because we understand how signs work, right? And when you label this triangle, the x value is a +3, the y value is a -4. Now, just for clarification, the length of the side is 4, because lengths have to be positive. But the vertical displacement, for all my physics peeps, is -4, okay? And then this is 5. And earlier today, after we were done, somebody goes, how'd you know it was 5? Well, I knew it was 5 because it says it right here. But if it didn't say that right there, and it didn't tell me, what would I do to figure out what the radius is? Pythagorean theorem, exactly. So again, don't make it too hard. It's Pythagorean theorem. You've been doing that forever also. But they gave it to me. So since I'm worried about, it's talking about the fourth quadrant, this is the triangle I'm actually using. So when I want the sign, that is y over r. But again, if you don't think of it that way, that's fine. It is also the opposite over the hypotenuse. You get the exact same thing because it doesn't change what it actually means. Cosine is x over r, or adjacent over hypotenuse, which is 3 over 5. And tangent is y over x, or it is opposite over adjacent, however you, opposite over adjacent, -4 over 3. Everybody okay with that? Okay. Just let it marinate. You have like 5 seconds to let it marinate before you take a test tomorrow, but I really think maybe seeing some of this, if you get to some of these questions, you might be able to reason through more than you think you could. All right, so, oh goodness, I'm about to run out of time. Let's just talk here. I'm going to kind of skip through this then. Here's what I want you to get out of this, is that this P right here, this point, if it gets reflected over here, we've reflected across the y-axis, therefore we change the sign on x. Then we reflect in the x-axis, therefore we change the sign on y. Plus, we know how the signs work in the quadrants, right? Then we reflect, this would be x -y. And these 4 triangles that you get here, they are all congruent. And then all these angles would actually be the same as well, right? So just think about the triangle itself kind of getting reflected. And then we're going to look at example 4. Then I have one other thing that I need to show you. It's going to require this, so let's turn that on. Bluetooth pairing. All right, so if you had something like, this is what happened last time, and it's not going to pair. That's okay. I'll just talk through it. We're going to find the sine of the angle whose terminal ray intersects the circle at point S. It would more likely say something about the terminal ray, here's point S, being in the 4th quadrant, so that you would then know you're looking at this one. And since the terminal ray is in the 4th quadrant, these are my x is positive, my y is negative, and I'm looking for sine. And sine is, this is a -y, this is x, this is r. So it is just going to be your y value, which is -y over r. Okay. Let me go back here and show this little video. We're going to write something at the top of that page here. Sorry, this wasn't on here. We got 5 minutes. We got time. I don't have time to make sure my Bluetooth's working. I think it's because I unplugged my computer. It gets mad. Okay. All right, so this is like literally a 30-second video anyway. So we're starting with, we just have a little line segment here. And we're going to make a circle. Okay? And the radius of this circle is r. We're going to take the length of that radius, and we are going to wrap it around the circle. Okay, that length, it wraps around. And then what we get is an angle that measures 1 radian. All right, because we're going to talk about radians here. You can measure angles in degrees and in radians, and trust me, I'm going to do a much better job teaching you what radians are when we actually learn it. But this shouldn't be brand new, so maybe it'll dust off some cobwebs for somebody. You can measure angles in radians or in degrees. You can measure a line segment in centimeters or in inches. Okay, it's just a different way to measure it. So the 1 radian is the length of the radius. No matter how big or how small the circle is, that's how much of the circle 1 radian would take up. One of the sample questions I saw said like, 1 radian is about how many degrees? Okay? I'm going to show you how to figure that out. You don't have to know that from the top of your head. But if this picture's in your mind, you know it's at least less than 90, right? And then you could go from there. But all right, so since there's 1 radian, go around to half the circle, you're going to get a little bit more than 3 radians. That actually ends up being pi radians. All the way around the circle is 2 pi radians. So 2 pi r is the circumference of a circle, and you also have 2 pi radians there. Now, on your reference materials, it not only tells you that there's 360 degrees in a circle, it tells you that radians, there are 2 pi. So there you go with that relationship, even if you don't fully understand it. And so if we had to convert, we know that 2 pi is the same as 360, and we know that pi is the same as 180. You can get that from the reference materials. If I want to do a 60-degree angle and convert it to radians, you can either multiply by 180 over pi or pi over 180 to convert, but you can also just do a proportion. I know that there are pi radians and 180 degrees. I want to know how many radians are there in 60 degrees. It's just a proportion. Cross multiply and divide, and you'll get 60 times pi divided by 180. And then once I cross that out, I get 6 over 18. That is pi thirds. Because it might ask you to convert. And if it does, this information right here is on the reference chart. You can go from here to here. Just set up a proportion. Y'all are good at proportions. Okay? What questions we got? We good? Awesome. Whew.